Hi everyone, this is your lesson for 3.1, pairs of lines and angles, and we're going to start with some definitions of parallel lines, skew lines, and parallel planes. So something to note is that parallel lines and skew lines do not intersect, right? They both are sets of lines that won't intersect. However, parallel lines are coplanar. Skew lines are not coplanar. That's the difference, okay? It's really important. And then parallel planes are just two planes that don't intersect. You do want to pay attention to capital and lowercase letters. They have to be the same as the diagram. So if the diagram uses lowercase letters, you use lowercase letters. We just want to make sure it's consistent to what we're talking about. And then lastly, you can see highlighted in the teal color or green, two vertical lines stands for is parallel to. So for example, M is parallel to N. Those are referring to the lines, and that's the notation. There is no notation for skew lines, so we write skew lines. Okay, let's go ahead and jump in. Now, these questions are very specific, so I'm going to do something slightly different. We're going to only use the diagram, and then I'm going to list parallel lines or skew lines, and then I'm going to circle which one actually answers the question, just for extended practice. So looking at the picture, I'm going to start here, parallel to GH. So I'm going to do parallel to GH in blue. So first of all, here is GH, and I want anything parallel to it. So parallel means it has to be on the same plane. And remember, there are planes that kind of cut these diagonally. So here is a line that's parallel. Here is a line that's parallel. We could cut a diagonal plane. And so here is a line that's parallel. So I'm just going to write these down. AB, EF, and CD. So these are all parallel lines, and then the one that contains point F is really what they're looking for. And so this one is the answer to the question. But I just wanted to practice identifying where we could see parallel lines. Okay, looking at the next one, we're going to list skew lines, and we're doing it to GH as well. So I'm going to change my color here, and here is GH again. And I'm doing skew lines to GH. So remember, they cannot be on the same line, the plane, but they do not intersect. So for example, I could do A to D. These do not intersect, but they're not on the same plane. So that means I could also do B to C. I could do A to E. Okay. I could do B to F. And that looks pretty good. So let's just go ahead and write those down. So I could do A to E. So line AE. I could do line BF. I could do line BC or CB and AD. Okay, and then it's saying that it wants it to contain point F. So if I was only answering this specific question, it would have to be BF. So just, again, giving multiple examples to skew lines, but then specifically answering the question is the one that we bubbled. Okay, perpendicular lines. So perpendicular lines, they intersect at 90 degrees, so they do have to touch. And again, I'm just going to change colors here. So we're going to do perpendicular lines to GH. So here's GH, and I'm doing anything perpendicular. That means they meet at 90 degrees, and I could do DH and GH. I could do EH and FG. Now, don't let the picture confuse you. They might not look 90 degrees because of the angles it's drawn, but this is a cube, a rectangular cube, and we want to make sure that we keep in mind rectangular cubes all meet at 90 degrees. So important. Okay, so I'm going to list those four. So we have EH, FG, GC, and HD. So those, again, are all perpendicular, but when I'm going in here and looking for the specific containing point F, the only answer that we really would give is this one, but I just wanted to show us for practice what could be considered perpendicular. Okay, and then it says planes parallel. So again, I'm going to switch colors here, and I'm just going to do, oops. Let's go ahead and do kind of a yellow. Okay, so we're looking for a plane parallel. So I'm going to actually highlight this plane. So GHD is this side of the cube. It's this plane right here. And if you're looking for a parallel plane, the only one can be straight across, right? It's never going to touch or intersect. And so how do we name that? Okay, and I would name it maybe plane ABF. Okay, now you could name it multiple different things. You could name it plane BAE, and even though you named it not containing F, it still does contain F on the plane. So there's different ways to name it. Remember, 3 letters, that's how we name a plane. Okay, so let's go ahead and look at this next page. So we have a parallel line postulate, which basically says if you're given a line and any point, you can create a parallel line. Like that is what it's saying, is if you have a line and a point, you can create exactly one parallel line. Same thing, if you have a line and a point, you can create exactly one perpendicular line. That is the perpendicular postulate and the parallel postulate. A couple things to note, notation-wise. These arrows mark parallel. Okay, and then what we notice here, 90 degrees, marks perpendicular. So just paying attention to, again, the notation and how we see that. So if you see 90 degrees, we should know, boom, perpendicular. If you see those arrows, parallel, okay? So looking at example 2, again, I'm going to try to highlight some things to make it a little bit clearer. So here's a road map that we have, and we want to name one pair of parallel lines. Now, there might be multiple, but we're looking for one pair of parallel lines. Do not assume, we have to know for sure. So I'm just going to come in here. See how this has 2 arrows and this has 2 arrows? That means that these lines, okay, are parallel. Now they look like rays, but we can name them lines because lines go on forever. And so make sure you use that correct notation. So I'm going to say line DM, okay, is parallel to line EF. So those are parallel lines, okay? Naming a pair of perpendicular lines. So shifting gears, okay, perpendicular lines meet at 90 degrees. And so we see that right there, okay, on our map, 90 degrees. And so I see it on this line and BF. Those 2 lines are meeting at 90 degrees. So here is what we can say. Line BF is perpendicular to, this also means perpendicular to DM. Okay, so parallel, perpendicular. And then the last one, it says, is EF parallel to AC? So is EF, let's find that first, EF parallel to AC? Okay, we would say no, because they will cross eventually. Okay, you could be specific and say that they have different slopes. They're not marked parallel, okay? And so we just have to be really careful with that. Okay, cool. So, looking at angle pairs. Now, the words give us some clear identities for these angles, but we really do have to be able to name them and know where they go. So I'm going to read through these. I'm going to mark some important information, and then we're going to draw them out for ourselves. If you have colors or highlighters, I do think it's important for this next page. So these are angles formed by transversals. And what it means is that a transversal is something that intersects two lines. So if you have two lines cut by a transversal, okay, then you're going to create these things. So the first one, you can create corresponding angles, okay? Corresponding angles means that they are in like corresponding spots. So for example, 2 is above the line to the right of the transversal. 6 is above the line to the right of the transversal. So above, it'd help if I spell it right, above line, right of transversal. Okay, you could also have like below the line and to the left, or above the line to the left, as long as they're in the same spots corresponding, right? Then they would be corresponding angles. Okay, the next one is alternate interior angles. Okay, alternate means opposite, right? That's alternate means opposite sides. Interior means it's inside. So I could have them here, right? We see it 4 or 5. 4 or 5. They could also be in those opposite diagonals. So we're giving you examples. We'll name them. We'll label them all later. Okay, let's go ahead and do alternate exterior angles. So again, alternate means opposites, right? On opposite sides. And then not inside the lines, but exterior, we're outside the lines. And so we see this at angle 1 and 8, or they could be on the other exterior, and we'll see that on the second page. And then the last one is consecutive interior angles. Consecutive interior angles are when they're on the same side, interior. Consecutive means same, so same side, interior. Okay, so with this in mind, we're going to go ahead and flip the page, and we're just going to identify all of them, okay? And we're going to use colors and try to like label where they could go. Okay, here we go. So first of all, a transversal is a line that intersects two coplanar lines at two distinct points. Okay, so this diagram right here is really similar to what we're going to start to see this chapter, and we're going to actually do some proofs, like prove angle 6 is congruent to angle 8, okay, or whatever, and we're going to go ahead and be able to do that. So let's get started. Vertical angles. Vertical angles, remember, are two intersecting lines, and they're kind of like a bow tie. So I'm going to create some highlighted parts that show vertical angles. This angle right here is a vertical angle to this one here. So I'm just going to go ahead and name 1, 2, 3, 4, 5, 6, 7, 8. Okay. I also have another pair of vertical angles here at angle 2. And here 3. So 2 and 3 are vertical angles. And then similarly on the bottom part, right, 5 and 8 are vertical angles. And 6 and 7 are vertical angles. So again, just trying to give you a visual of what those kind of look like. Okay, corresponding angles. I'm going to name this 1, 2, 3, 4, 5, 6, 7, 8. Now, corresponding angles have the same position. So, watch what happens. If I have angle 1, okay, it's above the line to the left. Above the line to the left would be angle 5. So, angle 1 and angle 5, okay, are corresponding angles. Angle 2 is above the line to the right, so angle 6 is also above the line to the right. Angle 3, below the line to the left, so I go below the line to the left. There is my corresponding pair. And then 4, below to the right, 4 and 8. Those are corresponding pairs. And actually, I really like the way that looks, so I'm just going to come over here and fix the way I highlighted these. So really quick, I'm just going to go 1, oops. Okay, 1 and 4, 2 and 3, 5 and 8, 6 and 7. Okay, so we have 2 sets already good. Alternate interior angles. So alternate interior angles, there's not nearly as many, but let's talk about them. I'm going to label 1, 2, 3, 4, 5, 6, 7, 8. Okay, now think of the name. Alternate, so opposite sides. Interior, okay, interior. So if I have angle 3, it's interior. The opposite of it is 6. These are alternate. They're on opposite sides. Interior, inside the lines. And then 4 is an alternate interior angle to 5. Okay. Alternate exterior. So very similar. I'm going to name, and then I'm going to do alternate, so opposite sides, but exterior. So 1, it's on the outside. Alternate exterior is 8. 2, oops, didn't change my color. Okay, 2 is an alternate exterior to 7. They're on opposite sides. That's what the alternate means, exterior on the outside. Okay, now, your math book, Big Ideas, calls them consecutive. To help us, consecutive, I think of same side. Okay, consecutive means in a row on the same side. Okay, so same side interior angles. I'm going to go ahead and number them. Okay, so same side interior. So 3 and 5 are same side interior or consecutive interior. And then 4 and 6 are same side interior, consecutive interior. And then our last group, 1, 2, 3, 4, these are actually not really taught in big ideas, but they are really important. And we also have same side exterior angles. So same side exterior angles are going to be 1 and 7. Now these are not called consecutive because they're not in a row, right? 1 is not in a row with 7. So we just call them same side exterior. And then my last one, 2, is a same side exterior, 2, 8. So knowing those locations, again, are so important because when we get into proofs this chapter, you're going to have to use those locations with like congruent statements, which we'll learn later, and how to kind of pull it together. So go ahead and practice your homework. And if you have questions, you can always find me and ask.